Hey everybody, this is Larry. This is me going Q2 of the bi-weekly contest 151. Find the number of copy arrays. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. So this one, I think it, honestly, I think there's all these explanation or like all these words and all these things. But I think the best way to think about the problems like this is visualization. And that's why I'm bringing up my drawing board. Yeah. But basically, the idea here is that okay, so you're given essentially a line, right? Of the oops. So you could have something like yeah. So then you have the array indexes on this dimension, and then maybe the values here. So then you have just like points. Right, and you could kind of maybe think about them as lines. It doesn't really matter, right? Because then now, because the line part, I guess, does actually matter a little bit because it denotes the delta, right? And then now, what we're trying to find in this problem is that okay, keeping in mind that because the reason why we want to draw this line is because if you have this visualization, then you will understand that every point along this line depends on the first point. So only the first point matters in a way. Unfortunately for this one, the first point is the range is big, right? So you can't just like brute force try every first number because it goes up to 10 to the 9 or something like that. So then what you can do, however, and the first thought I had honestly was binary search, but I knew that it wasn't going to work because sometimes if you get there's no monotonicity, right? Meaning that you can though maybe you could ternary search honestly, but still it's going to be a range, right? And the idea here is that now instead of the first number, we just look at the first number as a range that they tell us, and then now this is the constraint, right? And of course, for every number, there are different constraints. This could be more tighter, this could be more longer, and it doesn't even have to go up or down the same way. It can have, way asymmetric for whatever reason, maybe not negative, but you get the idea, right? And then the idea here is that, okay, well, if we want to copy this line, translating it up or down, which is basically what we're doing when we adding to the initial value or subtracting from the initial value to get the bounds, then now we can think about what are the lower bounds, right? For example, for this one maybe it goes to, oops, this is not a good looking straight line, goes up to here, which is no good. So then now you maybe want to draw this backwards, and then now you know that the new upper bound is here, because anything higher than that, you don't get it. Same idea with here, but with lower bound. And pretend they're straight lines, right? So you have here, right? So then now here, this is the range of the lower bound and the upper bound, right? Yeah. And then here again, we do the same thing, right? Kind of. And then now we just kind of, and then here, so the upper bound actually didn't change because this is the delta from the point to the thing, and in theory if you have a longer thing it doesn't change. But then on the bottom part you see that this actually, again, put in that they're parallel lines, then you can see that it matches here, right? And then you just kind of carry it all the way through, and that's really the idea for this problem that I had visualizing it in my head during the contest, during the virtual contest. And yeah, and honestly, when I saw this one, actually, it only took 3 minutes. That's not so bad. I honestly did think that it was a little bit annoying to implement, but I did YOLO a little bit at the end because I was like, some of it is experience. I was just like guessing a little bit because from experience, but I kind of vaguely knew it was roughly right. I just wasn't sure about maybe like some of the signs or something like this. But yeah, but this is basically it. We start off from the first element, the lower bound and the upper bound. We don't even care about the original value of the first number except for its relationship to the second number, drawing that line, if you will, right? And that's where delta comes from the first element. And then the lower bound, this is basically just a way of cutting it off to what we were saying, because we want to move the lower bound to the new point on the I, so then you add it by delta. But if that's higher than the, or if the bound is, oh, this is the lower bound. Yeah, if the lower bound it's tighter than the bounds, then we have to use the new bounds, and that's basically it. And of course, because this is how do you say it? Like integers on this interval from low to high, and we're just basically translating low from high. So you can think of this as low high on the 0th index, and then this conversion without the bounds. Like if we kind of think about this without the min and the max thing, then it's just converting the low to the high plus the delta, right? So drawing those lines, but then the bounds here will keep us bounded inside the new bounds that we're having. And of course, at the end, we just count the number of integers inside those bounds, and that's it. Of course, making sure that it is at least 0, because you can have negatives if you, I mean, you could also, depends how you write it, of course, but you get the idea of how it could be negative if the upper bound is too low or whatever. Anyway, yeah, this is gonna be linear time, constant space, right? I hope I don't have to go over that one, and that's pretty much it. When in doubt for problems like this, see if you can visualize it. I focus a lot on visualization on my channel, because that's how I solve it, right? I mean, not, you don't have to, but if you do get stuck, maybe see if that's in your tool set. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you could watch me solve it live in the contest next. I mean, I could have misread it. That was too fast, honestly, but Copy 5 minus copy 1 minus 1. Say what? Number of possible arrays copies such that, okay, so you have the original array, you have copies, and the deltas are the same, but the bounds are, okay. Everything's just determined by the first number, right? Okay, let's see. So we can't do a for loop for the bounds. It's just binary search on the bounds, right? No, that's not true. Because some can go too high, some can go too low. So I don't think that's binary search. Just carry the bounds forward, right? So okay, so upper, lower for each one, and then that's it, right? Okay, fine. How do I want to write it though? I mean, the original even doesn't even matter. Yeah, this is so annoying to write, maybe. I don't know, try to figure it out in my head before writing it, but maybe it's just fine, right? And then low is equal to bounds 0. Oops. Right, so we start at 1, right? Delta is equal to 0. Okay, so then now we want to update low. Lower bound is equal to either the new lower bound or low plus delta, right? Something like this. I don't know. This is just by symmetry and experience, so I don't know if this is right, but something like that. Ooh. I mean, the negative one makes sense, but yeah, and then we just max this of 0, and you could early terminate, but I think this is fine, right? Yeah. honestly, that problem, it was all intuition, so I didn't really slow down to prove it, but it makes sense. I'll draw it out later in the explanation. All right. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.